today's lesson, in section 7.5, we'll be doing more trigonometric equations. So example 1, we want to solve for the following equation over all reals. So here, now, when you have a problem where it has sine and cosine in it, and there doesn't seem to be anything else that would be able to tie them together, what we want to do is use our trig identities to help us make this easier for us. So one trig identity you know is that sine squared plus cosine squared equals 1. So if I use that to my advantage, I know sine squared is the same thing as 1 minus cosine squared. So if I insert that in, now I'm able to get all my trig functions in terms of cosine. So then I'm able to deal with this problem like I did previous problems in the previous video. So here I want to distribute the -6 through, and I want to subtract this -7 cosine to the other side so that I can make a trinomial. So here I get 8 minus 6 plus 6 cosine squared, x minus 7 cosine x equals 0. So let's reorganize. So I get 6 cosine squared x, and then minus 7 cosine x, and then 8 minus 6 would be plus 2. Okay, so here, now when I'm doing my factoring, I have a minus and then a plus. Okay, so that means that would be minus minus. I know that each of the first ones need a cosine, so now I just need to figure out my factors. Now there's only one set of factors for 2, which would be 1 and 2, so we can put them wherever. Now I need to figure out factors of 6 that combine with the factors of 2 that give me this -7. So here, if I think about my numbers, if I do 6 and 1, I don't believe I'd be able to get what I want. So let's try 3 and 2. So in that case, if I orient it so it's 3 with the -2 and 2 with the -1, then I think when I multiply the outsides I get -4, and the insides I get -3, so that gives me -7. So this would be the winning combination. So here I need to set each equal to 0, so that I could solve them individually. So I add 1 for this first one, and then divide by 2. Gives me 1/2. Add 2 for the second one, and divide by 3. So here, if I do the inverse, or think about all the values for x that give me 1/2 for cosine, so then that would be pi over 3, and also in the fourth quadrant it would be 5 pi over 3. Now remember, we're talking about over all reals, so I need the plus 2 pi k. Okay. Here, this one's not on the unit circle, so I need to do the inverse for the first one to help me out. So doing the inverse gives me 0.84. That would be what's plus 2 pi k as well. Now, I need to find the other one, which is in the fourth quadrant as well. So I need to take 2 pi minus 0.84, which would also get me 5.44. and that would be plus 2 pi k. So I have 1, 2, 3, 4 answers. Okay. For the next example, now we start having problems where you have a number or a period change inside the x value. Okay. Now, at the beginning, you don't change any of your thought process for this. Okay. So I still want to solve for tangent like I did normally. So here I want to add 5 square root of 3 over to the right because there's no other tangent, so I can get this one isolated by itself. Then I want to divide by the 5. Fives cancel out, so it gives me square root of 3. Okay, once again, we're in the first quadrant for inverses anyway. I want to find the ratio or the angle measurement that would give me a radical of square root of 3 after I divided the y over the x. So here, let's try pi over 3. So that point is 1/2 comma square root of 3 over 2. So then square root of 3 over 2 divided by 1/2, which would be the multiplication of 2 over 1, which gives me square root of 3. Okay, so then that would be one answer. Okay, and then the other one for tangent would be on the opposite side, remember. Okay, so it would be this one down here, which is going to be 4 pi over 3, because their point is going to be negative 1/2 comma negative square root of 3 over 2, which gives you the same thing, because the double negatives makes it positive. So 4 pi over 3. Now this is where it changes, so it's not just equal to x, it's equal to 3x. Okay, now what we're doing here is we're going to solve for x by dividing by 3. But because of this changes your period. So if you go back and think about when we graphed trig functions and how the number in front, when it changes the period, it also changes the number of answers, or like graphs of like the repeating graphs in between the same interval that we were looking at. So usually 0 to 2 pi, we would have a certain number of answers there. So if I made the period smaller, which is what the 3 does, by 1/3, so it squishes it, so you put that same picture, squeezes it, so you fit 3 total periods in the same section. Now, the period for tangent is pi. Okay, so let's act like we were talking about all reals for right now. Ignore the 0 to 2 pi for the time being. So let's say our answer was pi over 3 plus pi k, and plus pi k for this as well. And then I want to divide by 3. So that means I divide by 3 to each of these. So here, x becomes equal to pi over 9 plus pi over 3k, and then also 4 pi over 9 plus pi over 3k. Now, because we're in between 0 and 2 pi, those answers, those pi over 3k, don't really matter, but they do help you find all the other solutions that happen. So like I was saying, for tangent, if you were graphing it, okay, so we would have this picture, right? So in between pi, or 0 and pi, there's a 1 period. So now what you're doing is a third of that. So let's do this in a different color. So now I'm saying that a third of this okay, so I'm saying that oops, no, that's what I missed, sorry. There you go. There it is. I was missing that part. Oops. Okay, so notice how we squished it, so now you have 3 times as many periods. So here's 1, here's 2, and then here's 3 periods in the same length that it would take for a normal period. So that means I'm going to have several more answers to deal with. So this pi over 3 comes in handy, because if I start with pi over 9 for a first answer, and I add pi over 3 to that answer, it'll get me the next solution that's possible. So that'd give me the same thing as 3 pi over 9, so that's 4 pi over 9. Okay. Now what this tells me, as these are matching, so then they overlap answers on the same period. So I don't have to do it separately for 4 pi over 9 too. I can just continue on. So adding pi over 3 to this, which is the same thing as 3 pi over 9, gets me 7 pi over 9. Then adding it again gets me 10 pi over 9. Now I'm going to keep doing this until I get to a number that's too big, so it's outside of the 0 to 2 pi range. So then 10 pi over 9 plus pi over 3 gets me 13 pi over 9. Then 13 pi over 9 plus pi over 3 gets me 16 pi over 9. Now the next one would get me 19 pi over 9, which would be too many. So my answers would be pi over 9, 4 pi over 9, 7 pi over 9, 10 pi over 9, 13 pi over 9, and 16 pi over 9. Okay, so which makes sense. Before I was going to have 2 answers, so since my period increased by a rate of 3 being fit into the same period, so I should have 3 times as many answers. Okay. The last problem, it's kind of like the first one where you have a trinomial, so I need to factor first, but I have this 2x, so my period is changed as well. So here, cosine of 2x, cosine of 2x, minus means minus plus, or plus minus, whichever one you want. So I have factors of 4 and factors of 3. Okay, so now I need to figure out how I can get a 4 in there. So here, if I did match the 3 up with the 2, and I want a negative 1 or negative 4, so I want to do negative 3 with the 2. So then the outsides give me negative 6, the insides give me a positive 2, so that would give me a negative 4. So let's split them up. Set them both equal to 0. Here I'm going to add 3, here I'm going to subtract 1. divide by 2 for each. Okay, now over here this is greater than 1, so there's no solution for that one. So you don't have to worry about those ones, so all I have to worry about is 1/2. Okay, I'm still in between 0 and 2 pi, since this is just a continuation of the last example. So cosine, where cosine equals -1/2, would be 2 pi over 3 and 4 pi over 3. Okay, remember that's equal to 2x. And I want to use the period for cosine. Tell me find the other answers. So it'd be, this case would be 2 pi k. Okay, because my period has changed because cosine and sine have a period of 2 pi. So then now I want to divide everything by 2.